slideshow clearly explained the physics of earthquakes in a simple and interesting way. The information and visuals helped make the topic easy to understand. This slide presents a creative and clear comparison between water ripples and seismic waves. The visuals and explanations effectively show how the same physics principles apply to both small waves and powerful earthquakes. This slide clearly explains how waves transfer energy without moving matter permanently. The step-by-step visuals make the concept easy to understand and very engaging. This slide explains the two main types of wave motion, transverse waves and longitudinal waves. In transverse waves, the particles move up and down while the energy travels forward, whereas in longitudinal waves, the particles move back and forth in the same direction as the wave. The diagrams and examples make the differences between the two wave types easy to understand. This slide explains the parts of a transverse wave. The highest point is called the crest, and the lowest point is the trough. The wavelength is the distance between two crests, while the amplitude shows the wave's strength. The wave moves forward, but the particles move only up and down. This slide explains a longitudinal wave. Compressions are areas where particles are close together, and rarefactions are areas where particles are spread apart. The wave moves forward while particles move back and forth. This slide compares transverse and longitudinal waves. Transverse waves move particles up and down, while longitudinal waves move particles back and forth. Transverse waves have crests and troughs, while longitudinal waves have compressions and rarefactions. The slide also connects these waves to earthquake waves. S waves are transverse, and P waves are longitudinal. This picture shows that waves with long wavelengths have low frequency and less energy, while waves with short wavelengths have high frequency and more energy. This picture explains how earthquakes create P waves and S waves that move through the earth. P waves move faster, while S waves move slower and cause more shaking and damage. This picture shows how a seismograph records earthquake waves. P waves arrive first and are faster, while S waves arrive later and cause stronger shaking. This picture shows that earthquakes with higher amplitude create stronger shaking and have a higher magnitude than earthquakes with lower amplitude. This picture compares the Richter scale, which measures earthquake energy, and the Mercalli scale, which measures the damage and effects people feel. This video presentation on seismic waves was very informative and well organized. It clearly explained the different types of seismic waves and how they travel through the Earth.
Want to know a surprising fact about earthquakes? There are lots of them. In fact, every day scientists detect about 55 at locations all around the world. But there are many more earthquakes that go undetected, which is estimated to be as many as 500,000 a year. When these earth-shaking events are powerful and occur in areas where there are many buildings and homes, they can do a lot of damage to structures and injure people. But even earthquakes that occur in remote areas can produce changes to our planet, especially to its crust or outermost layer. You can see the impact of an earthquake in this image showing Earth before, during, and after the earthquake. Earthquakes are caused by the movement of the huge slabs of rock that make up Earth's crust. They are called plates. Earth's crust is composed of 7 major plates and many minor ones. These plates are always in motion, but sometimes they get wedged together along their edges. When this happens, the rest of the plate keeps moving, causing a large amount of energy to build up in the area where the plates are stuck. Eventually, the plates break free, and all that stored up energy is suddenly released. This vibrating energy moves outward, like the ripples on the surface of a pool of water when a pebble is tossed in. These vibrations are called seismic waves. They can be incredibly powerful, causing the ground to shake in all directions as they travel through Earth's layers. There are different kinds of seismic waves, depending on the type of vibration they cause as they travel through Earth. The action of this spring will help you understand how seismic waves are classified. When the end of the spring is moved back and forth, The vibrations move left and right along the spring. This is called a longitudinal wave. Now look what happens when we move the end of the spring up and down. The vibrations go up and down as they travel along the spring. This is known as a transverse wave. If we drew a picture of a transverse wave, it would look like the spring in motion. If we stop the motion, we can study the wave and measure it. The highest point on the wave is called the crest. The lowest point is known as the trough. By measuring the distance from crest to crest, or trough to trough, we can determine what's called the wavelength. Wavelength can also be determined by measuring from any point on one wave to the same point on the next. Another measurement we can take is the wave's amplitude or strength. This measurement is the distance from the center point of the wave to either the top of its crest or the bottom of its trough. Another measurement you'll often hear about in connection with earthquakes is magnitude. This is the strength of the earthquake in terms of the amount of energy that has been released. Scientists determine an earthquake's magnitude by taking a number of measurements and using a mathematical formula. The magnitude is stated as a number on what's known as the Richter scale. Scientists use an instrument known as a seismograph or seismometer to measure the seismic waves produced by an earthquake. The seismograph picks up the vibrations from the seismic waves and maps them on a piece of moving paper. The record of the seismic waves is called a seismogram. We've come a long way in understanding earthquakes, what causes them, and where they are most likely to occur. Of course, there's always more to learn. So as long as there are earthquakes, there will be scientists studying them.